All right, so again, EOC review. So we're going to do it pretty quickly. That anytime I do the EOC review stuff, it's just a reminder. This should hopefully have ingrained by now. But we've been using this all year long. This wasn't like a lesson where we just did it. You were gone like something. Two concepts in here. What's first concept? First concept. Giving company. Anything. So if you have a figure that's a triangle, this is kind of a bunch of lines, really, but it happens to form a triangle, so it's still a plot. Even if you don't have just one individual triangle, all of the angles, no exception. It's one of those no exception things. All of the angles of a triangle added together have to equal 180. Good. There. What? There. Let's see. Here. There we go. So that angle, and that angle does not matter that we don't know what that angle would. It wouldn't matter if we didn't know what any of the angles were. So again, I've told you many times. I'm going to keep telling you until you leave my class. I saw you walking to school earlier. How in the world did you just get here? Just circle whatever's in the angle. Whatever is in front of that degree mark, that's the measure of the angle. I don't care if it's 2x plus 20. I don't care if it's just a number. That is the measure of the angle. If it's got variables in it, or variables and numbers, we just don't know what it is. But that's the measure. So whatever's there is circling. Those three things you circle when it comes to triangles, those three things that you circle have to add up to 180. So we can, in this case, set up an equation. So next. Oh boy, London, here you go. Here's your shot. What's my equation? Now I've already told you the concept. Now you just have to be opposite. So I set up an equation for that. I can get it ready. Here. If those three angles have to add up to 180, what's the equation I would set up? You're solving it already, but let's try to set that. So that's correct. You get the answer right, but I like doing like all the steps in between, just because when I skip, sometimes it doesn't always make sense to everybody. But yeah, if you get that, that's perfect. You know how to set up the equation then for it. If not, I'll move on because you got that part down. Candy, what's the equation? Again, I just said all three angles have to add up. So you just write what's in every single circle, add it together. 58 plus 100. Again, doesn't matter if you can't solve it yet. Sometimes you won't be able to solve it, but that's still the equation. Whatever is in those circles added together has to be 180. Now, if there's only one variable, like in this case, we only have one variable, we can solve an equation with only one variable. So again, Lennon already told us, well, if you just add these two things up, so that would be 158. Well, in order to solve it, we would subtract 158 from that side, subtract 158 from that side. So I'm just going to write down here. Y is 22 degrees. That's the first piece. That's first variable. Isaiah, you get the slightly trickier part. What's the next concept, or how would I solve for x? So I now know this is 22. What's the concept? Do you remember? It's not the exterior. That would be parallel lines, which we're going to have a bell work on that coming up too. It has to do with a line. What's true about that bottom line, where the kind of the 58, the 22, the y, the x, the 71? Yeah, all lines, we said. All lines are called a straight angle technically, but they're 180 degrees. So if I know, and it's also kind of this is kind of like semicircles. We said a semicircle is 180 degrees. It's because it's half of 360. Well, a line is like kind of like making a semicircle. That's why we draw in that, or that's why we've always done it. We hadn't done circles yet back then, but that's kind of why we do that. That's half a circle. So that means a line is 180 degrees. We also said if you think about a right angle, 90 degrees. Well, if I add another right angle to that, I get a straight line, and that would be 90 plus 90, 180. Again, straight line is 180 degrees. So therefore, if I take an angle and I split it into multiple angles, so if that's 180 degrees, if I split it, those two angles still have to add up to 180 degrees. Right? I didn't change the line. The line was 180. It's still 180. I just split it into two. Well, if I split it again, those three angles have to add up to 180. Again, I am not changing the original angle. I'm just making more smaller angles out of it. Therefore, just switch to blue, I guess. That angle there, plus that angle there, plus that angle there. There are three angles there. It's getting a little. Anyway, let's get a little cluttered. Y plus X plus 71 has to equal 180. Oh, shoot, that's right. So it's been
Naomi, or sorry, were you on that?
here,
Adam Hassan,
here,
Israel Cristobal.
here.
So Adam and Israel, you got a good writing test in there. So
Those two?
Yep, we got a couple more.
I thought I had, I saw the list, I sort of got.
Cristobal M6. Shanti Phillips. Shanti, sorry, B4. Come on, get your ass, guys gotta go there now. Marcus Allen.
He's not good. It's those three.
I'll just leave those with you.
I thank you, sorry about that.
In case they show up in a few minutes, okay?
Cool. Yes, and one of them definitely could, so.
Okay, cool. That's fine.
Good luck. All right, so again, those three make up that line. You guys watch the video. Those three make up that line. If we have one variable we can solve, the way I wrote it, we have two variables, but what did we solve for a minute ago? Solve for y, right? So we would just replace y. We now know y is 22. You might not be able to see that. Let's change that color. There. So now we have one variable and we can solve for it. Again, two concepts that we used over and over again in class. The three angles of a triangle add up to 180, and angles that, the word is, I think, collinear. They call it different things depending on which book you use. I think this book called it collinear, just meaning that all those angles make up one line. So therefore, they also add up to 180. There was another one we made up that said the exterior angle of a triangle is equal to the two opposite interiors added together. So 58 plus 100 in this case would equal those two added together. Again, you don't necessarily need to know that. It could possibly pop up, but we'll do another bell work on that in a minute. All right. So that was the EOC review. Here's your circles quiz review. So that's what we kind of did is the lesson right before quiz. I want to see if we were. Whoop. Huh. See if you can figure that out. Not the full version of what we did, just a shortened version, but that's fine. So that angle, that is a, I'll just remind you, that is a central angle is the name of it. I want you to tell me, oh, and AB, it should have been A up here. Point A is right there. Point B is right there. If I just say AB with two letters, it's not matter where they went. That's automatic. Was. It's the exit. Oh, yeah, remember I gave you, so it didn't count against you if you didn't know how to do it, because we did the lesson right before the test. So what percentage of the circle is the 160? And then that led us to finding the length. Oh, the grades for you guys are in, by the way, from the quiz last Monday. Thanks, Kim. So, let me drag this down. Whoops. What? There. That's too bad. Right, so if you know what you're doing, it should be done by now. This is like the basic part or the core concept you've gotta have down. You don't have that down, you're gonna struggle on anything else that we do on circles. A central angle, the first concept we're gonna leave on. Yeah. How? What is the first concept about that? So what about the arc? Well, same measure in degrees, right? If we have, make sure you understand this, because it's gonna get real in about 30 minutes. Meaning I'm gonna start to throw a lot of stuff at you. The arc matches the measure of a central angle. Because think about it, this central angle, if we keep opening it and go all the way around, we're gonna have 360 degrees. Well, if we have an arc and we go all the way around, basically the arc is a whole circle, it's gonna be 360 degrees. So try to make that connection, that the angle is just gonna open up and go all the way around and be 360. It can go all the way around, right? Like if I kept moving this line here, if I kept moving it around, eventually it'll be on top of that. That angle just opened up to 360. If I kept lengthening, so here's my arc. If I kept lengthening it, I'd be eventually moving all the way around until I got to 360. We do the other angles for circles, that's not even possible. You can't open it all the way because the vertex is not in the center of the circle. So that's, you can separate those two things and it won't just be a matter of memorizing. It'll hopefully just make a little more sense to you that this central angle matches the arc. So with that in mind, I know that's 160. Now, what did we say a percentage is? Well, actually, we didn't do it. What's a percent or fraction or decimal? Any of them? They are all part of a whole. So again, the net, and that's not new. I mean, that's something you should learn. Fractions. All three of those things, not just fractions, all three of those things are part of a whole. Think of a pizza. You have a pizza, and this is always the fraction thing that teachers use. You have a pizza, I would say, what? How many pieces are normally in a pizza? I would say 8. So you have 8 pieces, right? If I say 2 pieces have been eaten, how much of the pizza has been eaten? 2 out of 8, right? So your fraction, if that's how much has been eaten, that's what we're gonna know. We ate 2/8 of the pizza. But what can I do with a fraction? I can just convert it to different things, right? How do I change that to a decimal? How just answer that. Ben, how do I convert that to a decimal? Yeah, I just take the top divided by the bottom. So if you do that, 2 divided by 8, and you should kind of know this, hopefully. So we ate this much of the pizza. So we ate that much. That's what we're talking about, how much we ate. You probably just looking at that would be like, well, that's like 1/4 of the pizza, 1/4 of it. 2/8 is 1/4. If you simplify that by dividing both by 2, it's 1/4. Well, you probably also know that's 25%. 1/4 is 25%. It's 0.25. All of those things are parts of a whole. Fraction, percentage, yes. And they're all the same numbers. Like you're just showing them in different ways. So with that in mind, we take the part and we divide it by the whole to get the percentage. That's the formula. Part divided by the whole, just like for a fraction. So what do we do with the 160? We're at now, Chloe. I want to find out what percentage. Remember, degrees is out of 360. It's not a percentage. I want to find what percentage of the circle that takes up. Take up what, like, does anyone want to guess? I mean, so you've got them. Is it going to be 70%? Is it going to be 30%? I think 40%, because it's less than half, right? Half would be if I kept going, definitely less than half. So always think about what numbers make sense before you do the math. A lot of people did not do that on the last quiz. I got a lot of answers on right triangles where the number didn't make sense. Like people solved for it, and I'm getting off track, but people solved for X, and this was 15 or whatever it was. People solved for X and they got a number bigger than 15. That can't happen. The hypotenuse is the 15, it's across from the right angle. It's the longest side. X can't be bigger than 15. Like there were a lot of answers that showed me that there was not a lot of understanding. We were just going through steps and plugging stuff in, and we did it wrong, but we didn't really understand the material. So those are the kind of things. Oh, speaking of which, Chance in London are the old account. So I put little exclamation points in to the grades sometimes, like in the notes or comments, whatever it's called. That means that it means a lot of different things. Basically, it means I feel like you understood it a little better than your grade. So if you see that, it's a good thing. It means that like maybe you made a bunch of math errors or something, but somehow you showed me you understood it. This is actually the opposite. If you said X equals 16, it shows me you didn't really understand it when you were going through and doing the steps. So if you see the exclamation points, just know it's a good thing. It helps you at the end of the quarter if you have a bunch of them with your grade, because I can say, well, they had a better understanding than what their grade showed. And I take that into account in the final grade. All right, so Chloe, back to Chloe. So how would I find the percentage of the circle that 160 is? We know it's less than 50. What would I do? It's a part of a whole. That's your key. But what part do we use over what whole? Over. Yeah, the part is 160 degrees. The whole is 360 degrees if I went all the way around. That's my fraction. And I can then convert that to, somebody do that for me because that's not going to come out nice. 0.44444.
Yes.
So we'll write exactly that, 0.44444, repeating. When you convert it to a percentage, you have to round. You don't typically, well, shouldn't say you have to, but you don't typically write repeating for percentage. So about 44.4% of the circle, which makes sense based on what we were thinking it would be. Now I didn't ask you to do this, but if you wanted to know the length of that, and I had given you like this line here is, I'll give you a different number this time. Now that we've done that, I want you to tell me how long AB, oh, I erased AB. I want you to tell me how long AB is. Arc AB. Yeah, you did it right before the quiz. You were gone Monday?
Yeah.
Well, we're solving really for the length. Actually, there are some questions on the next quiz that are just about percentages in circle, but no solving for a length, I believe. Yeah, we'll get to those today when we get to the book. this. Actually, here, let's just do this. There. So we know what percentage the arc is. I've given you a radius, which is the key. Chance. Wake up, bud. You need to be watching this. Helen, what was the key to me giving you the 5? Like, why did I need to give you the 5 for you to figure out the length of AB?
I need to find the circumference.
I can't just solve for AB. Oh boy. Whoa, it's like, whoa. I can't just solve for AB. There's not, I mean, there is technically a formula, but I'm not teaching you formulas. I want you to understand how to do things. But I know what percentage of the circle it takes up. I do have a formula to solve for the entire circumference. I guess I can leave it there. So I have a formula that can find the length of that line, basically the whole circle. That's the circumference formula. So if I know the whole circle, like if I could measure that line right there that's highlighted in yellow, and then I know, well, my arc I'm trying to find, arc AB, is 44% of that, so a little less than half of that, then I can figure out how big the arc is. Anthony, tuned in? Any idea how to do the formula for it? Oh, you would get the formula too, so I guess I should have given you that. So we'll just go ahead and solve it out since I forgot to give you the formula. If I'm given the radius, I would use the formula that had radius in it. If you want to use the diameter one, you just have to remember to multiply the radius times 2. So now we just plug in the 5. Somebody that did the math on that, what is 2 times pi times 5? 31.416, we'll say. What did I say? 4 what 6? 4 what 6? 1 6? All right, so somewhere around there. Again, I try not to round off in the middle of the process, or not round off as much. Like I don't want to make that necessarily 31.4. In this particular problem, it really wouldn't hurt you that much, but some of you did that on the quiz. Wait. That actually might have been my math for college algebra. So that's my circumference. Now, what do I do? Chance. I want to know what is 44.4% of that whole circle. So I can either, the calculator does have a percentage button, so you can just say 44.4 and then hit the percent button. Of means times. If I want 44.4% of 31.416, of means multiply. You don't automatically know that, you need to write it down. Let me finish this up. So 44.4%. If you want to, like, just to be safe, you can put it in as a decimal, which is what Chance said. 0.44444, you can put as many as you want. Here's what you cannot do, and every year somebody does this. Awesome. You can't put 0.444%. That means it's going to take that number, the 0.444, and divide that by 100, and it'll be totally wrong. That's why kind of having an idea of what your answer should be is helpful. I need less than half of that, so maybe like 14, 15, something like that. If you get a number smaller than that, then you should know you got the wrong one. What did it come out to be, the final answer? 13.94. 94. So yeah, we said around 14, 13, 14. Oh, it was higher at the end. So, and again, if you rounded that to 14, I would be fine with that. But you need to show me all the work before. So that was what we did Monday really quickly, right before the quiz. That will be on your quiz. Sometimes I don't repeat the exit tickets, but because we did it so fast, that will be on your quiz next week. Get your book pages out if you don't already have them out. Now we're getting into the new stuff. What? I didn't do it, but it should be. So if you in your calculator say 44.4%, you have to hit the percent button. Or you could just put in 0.444444, because that's the same thing as 44.4%. Remember, for a decimal, let's go over this lesson. I don't want to skip this, even though you have calculators. For a decimal, if you want to change it to a fraction, so that's probably what you were seeing on your calculator forever. To change a decimal to a, I'm sorry, to change it to a percentage, not to a fraction. So to go to a percentage, you move the decimal 2 to the right. So if I want to go to a percentage from a decimal, I move it 2 to the right. So 44.444. If I want to go from a percentage to a decimal, it's the opposite. I move it 2 to the left. Technically, what you're doing is you're dividing by 100. That's really what you're either multiplying or dividing by 100. Or you need to make sure you understand that throughout this lesson, because that could be on other parts of the quiz or the EOC also. Any other questions? We're gonna go backwards. Pages. There we go. All right, so we did example 1. Remember that check problem is. Oh no, that's just identifying ours. We don't need to do that. All right, so this is on your quiz. I looked at your quiz before I made the last quiz. This is on your next quiz. We just did it. So try to do example 3. Don't look at the solution. Just look at this stuff here. Just look at that that's in red. Ignore the other part because that's them solving it. And then try to do the check problem. You can do that. I'm pretty sure I just copied and pasted this question. I'm not probably changing the answer or like the numbers, but if you can do that one, that exact same question is on the quiz. Oh, what page is that? 201. 201. Thank you. Oh, did you find, speaking of it, did we find his volume 16?
Yes.
Perfect. How many pages does a volume take up?
Uh, 2 to 12.
Oh, wow. So he'll be going through those fast. Yeah, because sometimes we go through 12 pages in one class. Well, I don't know if we've ever gone through them all. Oh, no, not 12. That's not true. The practice problems take up a lot of pages sometimes. The lessons are normally the most 4 pages. So they should always be. I guess if you didn't get a pass today, you probably are testing tomorrow. I think it's whatever you. Yeah, it's. Oh, maybe. Well, now you're just testing one. Like they're not doing it with your English ones. That's the way they used to be. So it's like these kids just deal with just left on English right now.
No, I guess like.
Is it like 12? Or is it just?
9th and 10th, I think was. And I think they're mixed in. I don't think 9 kids like today get this smart. Yeah, it's all. What do you think?
My English teacher yesterday told me that we would all be tested on Wednesday. So I'm pretty sure it's whenever you have your English teacher on that day, you have it like.
But you're not going with that class. It's just whatever day.
It's just whatever day you have to.
Possibly. And they changed it from the way they normally do it to give you guys more time. Like, I don't even, they never even sent a schedule out. Hopefully they sent one out today. I need to look at that real quick. While you guys are wrapping those two up, do you have your pages? But you need pages out. We got a lot to go through and not always gonna be able to see up. I don't do a, this is more just for me to kind of show you which problem are on the book. See, it gets really, if I zoom in, it gets really fuzzy and it's really small if I don't zoom in. But you can tell which problem it is, obviously. That's all I really put it up there for. I'll leave that up while I see if they sent a schedule out for today. Let's see. This group, that's why I asked if you tore them out. We just tore them out last week. It was 189 to 254. You have them? 201, we said, I think that's it right there. Did you have your old book when you came over, or did you tear them out with me? Okay. I was curious. I don't see a schedule at all. Hmm. Hmm. Yeah, I don't even know what the schedule is for today. I don't think it's a normal schedule. I think we're in here for a long time. I think, oh wait, here it is. Test, is this testing? Um, it's not what I thought it was when I saw the title, but maybe this is where it is. Yeah, this is it. So yeah, we are, although he doesn't really say, doesn't say what the bell schedule is. He just shows when we're testing. So yeah, the best writing is I guess it started yesterday actually. And then it's today, tomorrow, and Thursday and Friday. So all week. I don't know if that's, oh no, makeups are next week. So I guess some people are testing all week long. I don't know how they have it broken up into which groups of kids are doing which day, but yeah, he doesn't have, oh wait, maybe the bell schedule's on the next. Um, no, that's also the ELA. So that's, there's no bell schedule in here. I don't know what our bell schedule is. Yeah, no idea. Oh, no. Let me do attendance really quick manually. Like everybody's gone. That's Adam. Shandy. Third is All right, so again, the question on your quiz says it's the same graph. This is called a pie chart, by the way. This is something you need to know how to read. A lot of companies use these. I use them in several jobs that I did. One of them I really pretty much my job was to read data, and I created these in a lot of situations. It just tells you out of a total set of data, what percentages does that data break down into? So like, let's say just a simple one. Out of all my students, I could create a really simple pie chart, and I have no idea if these are correct numbers or not, but I could say out of all my students, say 55%. So again, the pie chart is in percentages, not angles. 55% are girls, 45% are boys. So that would be the pie chart. It tells you out of your total, how are the percentages? Oh, I totally didn't know. Even though I was just talking about it while I was writing it. So that would be a really simple pie chart. You can break anything down. You have to figure out the percentages by making a fraction of them first. So maybe I have 200 kids total. Well, 110 of those are girls. So I would say, okay, well, 110 divided by 200 gives me 0.555555, or just 0.55. Well, now I convert that to a percentage. So that's what a pie chart is. Again, if you get a job at like at a what would be considered like a desk job kind of thing, a lot of times there's going to be some part of your job where you need to understand how to read, at the very least, how to read a chart. You might be the one creating. It's a good job. Like dealing with data, I think was and relatively, I didn't have to really worry about dealing with people as much and kind of leave it alone as long as you do your job. So dealing with data can be a really good job. One of my friends does that. She loves it. And you do pretty well if you understand how to do it. I guess we can go ahead and look at these now. So this is, I'll zoom in. It's not super clear, but you have it in your, oh, I can't zoom in. Here, I'm gonna slide this in. There. So here, I totally forgot to take your phone from me. I just remember normally I'm okay. So if I have this pie chart and it says kind of tough to see up here, so look at your book, 44% of what is it? So 44, this is probably not even close to accurate, it's probably way more than 44%. It says 44% of teenagers spend the majority of their time on social media. Probably more like for the kids here, more like 60 or 70%. But that means that almost half of kids, 44%, spend the majority of their free time on social media. Typically, what will then happen is they will say something like this. Did they do it in this? No. A lot of times they'll say, well, no, not in circles. They wouldn't say that. That would be a different kind of question. So I'm not going to worry about it. All right. So with that in mind, they want to know what. Oh, actually, DE, that's not the one they want. They want to know what is the length of DE. And I'm sorry, what is the percentage of the circle, the percentage of the arc? Right, so what is the arc in degrees? There's no length associated with a pie chart. So what would we need to do first? Did I go all the way around the room? Rand, what do you think we need to do first? So this will total 100. If it totals, so here's your note. Write this down, just to make it super simple. If you add the percentages up and they're 100, then you're gonna need to convert it to degrees. You're gonna need to convert it to how many out of 360. If you add it up like, and it's 360, then they've already given it to you in degrees, and you would be converting it to what percentage of 100. Oh, they do just want DE, thank you. I didn't really look at it. Yeah, because E is just right. So just one. For some reason, I thought they were adding sections together, but apparently not. So they could add sections together. Like on my quiz, I might have you adding them together. For some reason, I remember thinking that. I thought it was this example, but is it the next one? Actually, the next one doesn't either. So I maybe on my quiz I did it. Just know that if it crosses two arcs, you have to add those two percentages together. We don't have to. We just want this yellow piece. What is that blue arc? What percentage of the circle? Not what percentage out of 100. What percentage of the circle? So what do I do? Yeah, just tell me how you solve it. Yeah, we've already got the information that we solved for last time. Remember last time we figured out what percentage of the circle was the arc. Now we're going backwards. They're telling us what percentage it is. We just multiply it by 360. It's the opposite of what we did before. So if I know this orange section is 12% of the whole circle, I just need to say, okay, well, what percentage of 360 means I multiply. So I just say 12% or 0.12 times 360. So again, if you know the percentage and you're converting to degrees, so here's where you need to write notes down. If you know the percentage, I'm not going to write this up on the board, it's too much to write. Isaiah, I mean, you might have this down, but just if you know the percentage of the circle, again, not the degrees, you know the percentage of the circle. You see a percentage sign, that's a pretty big hit. If you have to solve for it and figure it out yourself, it's a little trickier to make the connection. But if you know the percentage and you want to convert to degrees, you're just multiplying times 360. If you know the degrees and you want to convert it to percentage, you're doing the opposite. You're dividing it by 360. And it's actually, again, proportions work great if you understand proportions. This 12% is out of what? Yeah, what is 12 out of? What's the whole? Yeah, 100%, right? We just said that earlier. Percentage is part of 100. Think about a quiz. Highest you can go is 100% on a quiz. Hopefully you get better than 12%. So 12 out of 100, if we want to know what amount of degrees that is, X is what we're trying to solve for, how many degrees, and then over 360 is the total. Part over a total equals part over a total. One's in percentage, one's in degrees, but the proportion has to be the same, always. So you would get, what would that be actually? 360 times 12 and then divided by 100. And you should have gotten the same thing if you just said, is that what you got when you just said 0.12 times 36? Should always get the same thing. Never be a time when you get two different answers or else something was done wrong. I'm not going to go over the check problem, but really quickly so you can check answers. So CD they wanted, what was CD, CD was basketball. What was basketball? What was the measure of the degrees for that arm? You got 61.2, you got like 630. Okay, so you did, I thought you were saying a difference. So somewhere around 61 point something is fine, depending on where you're around. And again, always check, I would always check my answer, make sure it makes logical sense. 17% is less than a fourth, right? Quite a bit less. So you could say, well, what is 1/4 of 360? Well, that's 90. Yeah, 71 makes sense. That's quite a bit less than 90, but still somewhat close to 90. Well, always kind of make sure your answer makes sense. That cost a lot of people on the quiz from last Monday. All right. Let's zoom out and just see where my rest of my presentation is. I think you should be able to do example 4. So try to do example 4 before we do kind of a new lesson. I mean, the other stuff, all of this is the building blocks for the next 2 or 3 examples. So if you have this down, it's the next stuff we get into is a little confusing, but it's the same math for one new concept, one new type of measurement. That's yeah, that should be good. Oh, don't look at what they did. Remember? If you have, then you can just do the check problem. Really the same exact thing. All can get is adding one concept to it. Not even a new concept. All right, I'm gonna go ahead and at least start on the example. You really should have been done by now. They only added one piece in. It's kind of what I thought that we were doing in the last one. Maybe this is where I got it from. They want to know how or what is the measure of arc WY. When they have that little M there, it's gonna really be in degree. Yeah, it's gonna be in degree. This is super. I was thinking it was more difficult. All we're doing is we're saying, okay, well, if I know that red arc is really 2 arcs, what do I need to do? I just had to make sure, yeah, this is not what I thought it was. I didn't really look at it. So I know that the only connection you need to make is that's 90 degrees. I know if it is a central angle, the measure of the arcs matches the measure of the central angles. So you're just adding those two together. So should have looked more closely at it. I thought we were still solving like for percentages and all that kind of stuff. We're not. So yeah, so the arc is what, 152. AD, kind of the same thing. I'm adding 63 and 90. So that was not anything complex at all.
As an example for also checking.
Well, the measure of the angle matches the measure of the arcs. Right? Is that the angle we're talking about? Yeah, so WVX is 90. That's where they got that. Is that what you're saying? Say it again.
I thought it was checking what the other side or the other arc would be on the opposite way.
No, that's not an arc. That's an angle. So you saw the three letters is what you're saying. Yeah, be careful. Remember, angles and arcs. Put your phone up, Al. Angles and arcs both can use three letters. So you got to look at the symbol. That means the angle. So they're just saying this angle right here, which is 90 degrees. That's where they went from there to there. Yeah, so, but an arc, a major arc would use three and would be telling you to go the other way, which they could ask you to solve for major arcs sometimes too, so just remember that. All right, so here's where it gets significantly more complex. And it's not even that the math is more complex, it's just a very weird concept. So we have this thing right here, called a radian. You have never before, not most likely, you've never before in your life seen it. That's not something I think that ever been covered in any prior math class, which is what makes it difficult. It's the first time you're ever seeing it. And the other thing that makes it difficult is it's kind of a weird concept. So every circle has a radius, right? Every circle. And circles get bigger or small, radius gets bigger or smaller based on the size of the circle. This concept of a radian uses two things. It's kind of a measure of length, but at the same time, it's kind of a measure of the percentage of the circle. So kind of like degrees, not really like circumference, but we will use it with circumference, just like we use the degrees with circumference to figure out the length of just a part of a circle. Like, oh boy, this is where it gets tough. A radian is based on the length of the radius. If I take a circle and if I measure the radius, and if I say, okay, well, I'm going to take that length, whatever it is. Actually, let's give it a look. I'm going to zoom in. Let's see if I'm on. Let's zoom in first. Tell you what, let's do this. Let's actually create a whole new circle, not just make a bigger circle. Nice and clear. There we go. Now, oh man, I should have put the center of it in better, but that's fine. Center is probably somewhere about there, maybe. I don't know. That's center, you think? I don't think that's the sense. Up or down? What do you think? Up, down, left, right? Down a little. That's what I was thinking too. Left or right? You guys are more straight on than I am. Left, right, or right there? Right. Think a little bit of the right. I was thinking right too, so we're gonna get it. All right, one to the right. So I now have drawn in the radius. And again, the radius from the center to any spot on the circle is always the same length, right? If I drew in more lines from the center out to the circle, it'd all be the same length. That's the key. Radius is always the same length. If that radius, actually, let's do this. Make it red. If that radius is 5, let's say, it doesn't matter what length it is. I'm gonna now take a length of 5. I'm gonna lay a string down that's 5 units long, piece of string. Make sure it's exactly 5. It's the same length of the radius. But now I'm gonna take that and I'm gonna take it off of the radius and I'm gonna lay it on the circle. Somewhere around there. So that is called a radian. If I take the length of the radius and I lay that on the circle, now that arc would be like 1 radian. So again, the length of the radius, but placed on the circle, like making it an arc, basically, is a radian. If I were to do that for any circle, it would always be the same number of radians that get me all the way around and back to my starting point. Always, no exception. I don't care how small a circle is, because it's always in proportion. Like if a circle gets bigger, well, the radius is getting bigger. If it gets smaller, the radius is getting smaller. So the proportion doesn't change. It'll always be the same number of those radians that I lay down to get me all the way back to the beginning. Right? Do you follow so far? Now is where it gets really tricky. To get all of the way around for any circle, so again, this is a radian. It's 1 radian. And it's a measure of 5, just like the arc is. I'm sorry, just like the radius. So to get all the way around, if I went, how am I going to draw this? Let's just highlight. We'll do highlight this. So if I go all, let's use green. I go all the way around, not going to be a super, actually that one. If I go all the way around, oh man, now I got rid of my radian. It would always equal 2 times 5. So the number of radians, again, I'd count them. I laid 1 down, 2, 3, 4, 5. The number of radians is always 2 times 5. So you can multiply that out. It comes out to be like, what does it want to be? It's 6 point something, or is it over 7? 2. Yeah. So it always comes out to be like 6.28 radians. That's how basically how many curved radiuses we lay down. 6.28, or the exact number is 2 times 5. So again, 6 of these, 6.28, blah, 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 6.28 of those every time if we were to do that for any circle. So what you're going to sometimes be asked to do is measure the length of an arc in radians, not in degrees, not in like what is the length, centimeters, inches, millimeters, all that kind of stuff. You're going to measure it in radians. Again, it's just a unit of measure. That's all it is. So here's your note. So Isaiah, Hal, wake back up. You at least need to write this down. It's always a percentage of a whole. It's not like length, like with inches and millimeters, where you can have any number. As the circle gets bigger, the units get bigger. This is always a percentage of a whole. The highest you can ever go is 2 pi when it comes to rate. Well, technically that's not true. Sometimes you could wrap around the circle and keep going. You'd have more than 2 pi, but 1 full circle is always 2 pi. Whereas a radius, if we measure the length, if the circle gets bigger and bigger and bigger, it could be any number. It could go up forever. With radians, when you get back to the beginning, kind of like with degrees, when you get back to the beginning of a circle, how many degrees did you go? 360, right? That's the top. Now, if you keep going, you can add more. When you get back to the beginning and you're measuring in radians, it's 2 pi for every circle. Now, if you measured it in length, you could go as high as you want to be, as high as you can build a circle, draw a circle, design a circle. All right. So now let's go back to the pages and try to work some problems. That was on. Oh, now let me zoom out because I have no idea how to put it back center on the screen. Radians. think we need to. Yeah. So there is a formula. If you want to memorize formulas, there is a formula. I'm again going to deal with the concept. You don't get any of these formulas on the. Was that? I can zoom in. You don't get any of the formulas on the reference sheet. Central angle is ratio of the arc to base circle. Again, that's still kind of, I'm not gonna, if you want to try to memorize the formula, you can. It says proportion. So again, when I say percentage, it's like proportion, it's like what percentage, what proportion of the 2 pi is it, or the 360 is it? Let's just go to a problem. All right, so look at example 5. And again, there's the formula right there if you just want to memorize something. If I know not even radians. All right, just do example 5. You should be able to do example 5. That's what we did at the beginning. I don't know why that one's way after the radian. They should have put that before the radians. We'll do the radians as example 6. So yeah, you should be able to do example 5. We did that. I mean, that was your lesson Monday before the quiz yesterday, and we did it at the beginning. It's on the quiz Monday. Gentlemen, wake up. You try this. Example 5. Same thing we did the lesson on yesterday. Same thing we did at the beginning of class right after the bell work. I don't remember if there are IXLs. I'll put some IXLs for sure though in there. Circle IXLs are good just because you get a lot of practice. And even though the IXLs aren't as difficult as some of the book stuff, it's good to get the basics down, I think. And some of them are pretty close to what you can. I'll give you another minute. If they say a radian is a unit of angular measurement, I would not have said that personally. I mean, it matches with this part. If you think of it, for me, think of it as part of the part. All right, so what's first step? On you out there, you're in London. What's first step? I need to figure out the percentage of the circle first before I can. So here's the key word in this, by the way, length. If they're saying length, that means you gotta do more than just the percentage of the circle. You'll still probably use percentage of the circle. But length means you're like gonna somehow figure out the circumference. Circumference is measured in length. If they just say find the arc and the word length is not in there, then you're just doing degrees. So you need to make a note of that. Length means you need to think I'm gonna use the circumference. Write that down. Length. You see that word length in the problem, that means you're gonna be probably using the circumference. Otherwise, they would just say like find the arc or find the angle or something like that. And then you're dealing with degrees or something like that. So with that in mind, I know that this 80 there we go. There. So this 80-degree arc takes up a percentage of the circle. What percentage would you have guessed beforehand? How? Yeah, we know 90 is 25, right? That's our go-to. Well, 90 and then 180, we know is half, 50%. So those are our two go-tos. 90 is 25%, 180 is 100 or is 50%. So if I'm at 80, I'm just below 25%. So anywhere in that 20 to 23 range as far as being a percentage of the circle. So I'll know when I do 80 over, Isaiah already said it, part over the whole. 80 degrees over the whole of 360 degrees will give me what percentage of the circle that red arc AB is taking up. What did it come out to be exactly? 2 repeating. I'm going to just say 20. I'll put a 0.2. That's fine. Put it. So 22.2% of the circle, which falls in line with what we were guessing, knowing that it's less than 90. Now I just say, okay, well, if I'm finding length, that's my key that I need to use circumference. I need to know 22%, 22.2% of the entire circumference. So we use, I didn't give you the circumference formula, but if you have it in your book, hopefully you looked it up or you just saw it right there. So I say, what do I need to do with that 14 though? 10. Well, if I use that formula, I could have just used the other formula too. If you use the diameter. Yeah, if I use this formula, I divide it by 2, but also remember, I have this formula and you have that on your sheet. So if they give you diameter, you can just use the 14, but then you just multiply it times 5. So just be careful, make sure you're using the right formula that matches the information they give you. What do you get when you do that? 14 times 5. It should be bigger than that. Yeah, because it's 43.9. So that's the whole circumference. D equals, I'll just say that. Not like that. So I need to know what is 22.2% of means multiply the entire circumference. So that's the entire circumference. I only want 22.2% of that. We multiply them together. Again, you can do 0.22222 times 43.9 or use the percentage button. But the key is understand I should get about 1/4 of that number. If I don't get about 1/4 of that number, I did something wrong with my decimal. Question? It's a little. Yeah, because right 10 would be about 1/4, and we're less than 1/4. So that whole, well, let's do it this way. The whole, and go ahead.
I just wrote
So the whole entire green line, let's do this. The whole entire green line is 43.9. The what is now in, actually, let's write over it. The red line, which is about 1/4 of that, 22.2% to be more accurate, is a length. So what was the answer again? I didn't write it. What is AB? 9 point something. Is that what I heard? 9.8. And then where you round, I don't really care. Unless that's supposed to, is that supposed to round up or
Yeah.
Okay. So that red is 9.8 out of the 43 point. All right, so I think we might get through everything. Although these two are tricky, but we're not going to spend any extra time on them. So now we need to take all those concepts and just add the one last piece of radians. It's the same thing we've done. It's just a different type of measure. As long as you understand, radians is always a percentage. It's not a length. You won't see the word length. It'll just say convert to radians or how many radians. It will not say length, which means you're not going to use the circumference formula unless they ask you to do something with the radians. I'll bring it up. All right, there we go. So they want us to take 135 degrees and write it in radians as a multiple of pi. Hardest part of this is just understanding what in the world they're asking you to do. So just really quickly, 135 degrees, how much of the circle is that? Approximately. Is it more than what? What's it? We know it's more than what? More than a fourth, because 90 is a fourth, so more than that. Less than half, and it's kind of in the middle of them, right? It's actually exactly in the middle. So if it's in the middle of 90 and 180, we have an idea where it should fall, right in the middle of 190 and 180. As far as a percentage of the circle. So anytime you don't see the word length, we're going to be, or really, even if you see length, you're still going to be figuring out percentages. First step, just like the other one, is what percentage of the circle is that? So you guys figure that out. What percentage of the circle is 135 degrees? And again, that is right in between 25 and 50, right in the middle. So it is 37.5% of a circle. Now then we have to say, all right, well, if that's how much of the circle, how many radians would that be? Well, it's the same thing. It is part of a whole. What is the whole circle in radians? If you didn't write that down, you need to write. I didn't really emphasize it. I should have. Say it again. A whole circle is the maximum for one circle. Just like the maximum degrees is 360, the maximum is 2 pi. That's the maximum number of radians. That's exactly how many radians, if you lay them all down, the length of the radius laid down, we said we'll get to 2 pi radians. So that's the whole. I want 37.5% of that. Here's the only trick. They don't want you to multiply the pi out. They don't want you to use pi. They want to leave that in there. So all you do is you say 37.5% of 2. You do not put pi in it. And then you just will leave pi in your final answer. You won't multiply it out. You'll just say, and then times pi. What does that come out to be? 0.75? Well, it's percentage of 2. It can't be 75. What percentage of 2? So you got to use percent or do 0.375. 0.75, right? So 0.75 pi would be your answer. Did they give you an answer on it? Yeah, well, they say 3/4 pi. I'm fine with decimals, but yeah, you may see fractions in it. Keep that in mind too. So they just didn't convert the 135. They're using the formula, which is, again, if you want to memorize the formula and when you use it, and you can put it on file now, I can show you work. I like you to understand. I think that will last longer than what you're doing. Probably can get away with that on my quiz, but then remember it all the way through EOC, all these formulas and tricky. So same concept. What percentage of the circle do we have? And then convert that into radians by just multiplying it by the total number of radians in a full circle. So try to do the check. I think there's a check problem, right? Try to do the check problem on your own. We'll go. And then the last one, example 7, is just going the actually 7 and 8. Yeah. So we'll practice this more next class also, and do the more difficult ones, 7 and 8. I mean, we're not done today, but then we do have a new lesson next class too. And oh, so your exit ticket. What would your exit ticket be out of this? I forgot to be thinking about that while we we're doing it. Let's see. No, Thursday. Not gonna give you the same one that was on the quiz. I could, but I tell you what, here's what I'm gonna do. Like, oh, that's Thursday. I'm not gonna. I was gonna say I'll give you 2. One that is the same one you just had. Give you another shot at that. But then the people that want either. Ooh, still wouldn't. You guys will miss tomorrow. Oh crap! That's right. You guys might not be here. So testing. Does anybody know they test Thursday? Everybody tests tomorrow. All right, then that won't matter for you guys. So here's what I'll do. I'm not going to give an exit ticket on what we did, the new stuff today, because they put this at all. I will give the same exact exit. So you're going to get the same time. It'll be like example 5. So write that down. Example 5 is your exit ticket for Thursday. And then there are practice problems. You can look at the practice problems. I'll show you in a minute. Anything where it says example 5 in the practice problem will be just like this. So you're just going to solve for the length of an arc. Remember, length means you use circumference when you see that word length. All right, so now let's go and do the check really quickly. Oh, that's all it is right there. Let's see. Chance, wake up. I'll do it. Got to prove it to me. Mapping, you must know how to do it, right? I want you to convert 240 degrees into radians as a multiple of pi. Maybe she's not doing it. All right. All right, go ahead. I want you to do it now. I'm going to start solving it. I just will cover it up so you can't see it. I could have frozen the screen on this. Oh, what is that? You can do it as a decimal or as a fraction. I don't care which one. Like I said, they're probably going to put it as a fraction. Oh, just want to do that. That's cool. Actually, yeah, I'll just. Your answer? I want to see what you got. Just. I really need some fraction. Good. So if you're comfortable with that, the last piece is a little trickier that we'll do it today, but then it'll be. Again, just know the fraction that would be the number. I mean, I know you're getting it, I can tell, but this is what cost you on days when you do this and miss some of the more challenging pieces that are harder to pick up later. All right, got it? All right, you keep your head up, man. All right, so we need, again, if it doesn't say lit, even if it does say length, you're almost always gonna figure out what percentage it's. And that's just what you're gonna always do. They're gonna give you degrees, they may give you something in radians, they may give you a lit, like, you're gonna always be thinking, I'm probably gonna need to figure out what percentage of the circle. Unless they just give you the percentage of the circle, like the pie chart. They just gave you the percentage, so we didn't need to figure it out, but we still use it. You're almost always gonna need that percentage of the circle. So I figured out the percentage of the circle. I didn't even convert it to a percentage. I just left it as what fraction of the circle. So for you guys, if you did it as a percentage, you probably would have gotten this. If you round it, 66.7%. So you then multiply that by 2 pi radians, and it looked like pretty much everybody was getting the answer. 1.33333 forever repeating. We just multiply just times the 2 if we want pi to be in the answer. I really don't know what they're going to do on the EOC, if they're going to have you like multiply times pi and give the answer at the decimal, or if they're going to give it with pi still in it. Just understand the difference. It's just we didn't multiply times pi, we just multiplied times 2. If there's no pi in the answer, then you need to multiply by the pi. All of these things are just being multiplied together. So if you don't have that symbol pi in the answer, then you need to multiply times pi also. The answer would also look like that. Again, if I didn't convert it to a percentage and I left it as a fraction, I would just say this fraction times 2 instead of percentage times 2. Or even better, just convert the multiple choice answers to decimals and see which one matches your answer. You don't need to understand how to convert your answer, convert all their answers into decimals. Figure out which one matches also. All right, so now we are going the opposite direction. I want to take radians and change it to degrees. So what do you think the first step's going to be? What did I say? You're always going to pretty much do this. And what percentage of the circle am I taking up? That's like your go-to. Unless they give you the percentage of the circle already, like they did in the pie charts. I need to know 11/6 pi. What percentage of the circle is that? I want you to try to figure it out, and then we're going to kind of go through a visualization thing. I mean, you really don't have to go through. There's an easy way to figure it out. It's, remember, percentage is part of whole. So they gave you the part, you know what the whole is. It's a little tricky to do in the calculator, which you probably figure it out. I don't know if it'll allow you to put that in, so fraction or not. I'll bet it probably doesn't, but you can try it. I tried to do 11. Oh, there it is. 11. Big. Divided by. Didn't work. And I didn't. No, 183%, because what is 11? Just 11/6 is what? Good. Wait, which one are you doing? You're doing this one, right? So what's 11/6 is a number? Your decimal. So how many in a whole? In radians. It's a whole circle in radians. Hello? Whole circle in radians. You need to make sure you write this down. I think you might have missed it when you were turning out. What's a whole circle in radians? Whole circle in degrees is 360, and radians it is 2 pi. So if you have 1.8 something pi, that's less than 100% of the circle, right? Because 2 pi would be 100% of the circle. 1.8 something 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 pi is less than. I'm trying to figure out a way that you can do. I mean, you can always convert it to decimals, I guess, and then divide that. So what's the concept though? How? What's the concept? What do we want to figure out? I said your go-to. What you go to? Well, not in this case. We're going to convert it to degrees. But in this case, just what's the general concept? We start almost every time by figuring out what. Unless they give it to us. So they do in a pie chart. So, what percentage of the circle are we talking about, right? I know. Visually. It's not a 11/6 is not a great number to figure out. What's half of a circle if it's in? I'm trying to think of an intuitive way to understand before I just show you math. Okay, what's a full circle? Well, you're doing degrees. We're talking about radians right now. Pi radians. What's full circle? 2 pi, right? So we know that's a full circle. Let's start with that. So 2 is the number we're focused on. What would that be if 6 was the denominator for 2? How would I change 2 into a fraction that had 6 in the denominator? A number with 6 on the bottom is equal to 2. No, you're doing 1/2, right concept, but we have to flip the thinking. 3/6 is 1/2. We want 2. So the top number got to be big. The biggest number at the top. If we're doing 2. 12/6, right? Well, if you need to use your calculator for it, you can do that. 12/6. If I divide it out, or if you just use your ABC button, it'll convert it for you. That's 2. So a whole circle is also, we could say 12/6 pi, because 2 is the same thing as 12/6. Okay. Do we have 12/6 up here? Lower or greater than 12/6? So we're not at a full circle. Okay? So we're less than 100% of the circle, but we're not real far off. We're only 1/6 off. So just as a quick guess, we're going to be, I would guess, 90-ish, something like that, like probably even a little bit higher than 90. That's the visual concept, is if I split the circle into 6, and I had 11/6, then I'd count 11 of those, and it would get me almost all the way back around. Again, I'm just going to show you the math. If you didn't understand that, no big deal. All I need to do to figure out what percentage of the circle that is, I know 2 is the full circle, right? 2 pi. I just need to figure out what number is that. Is it 2? Is it 1? Is it in between? So just how do I can figure out? You already did it. What was it? 11/6 is what number or value? No, just a number. You divided it out. 1.8. Yeah, 11/6 is 1.8333333. Does it repeat forever? So 11/6 is 1.83. Again, just short of 2. So what I want to do, and you can do it with the pi or without the pi, it'll work. If I have 1.833333 pi, That's the part they gave me. So what's the whole in radians? 2 pi is the whole. It's the same thing we did before, part divided by whole. You just have to kind of figure out how to convert this part into something you can use on the calculator, because you can't just like, at least I tried to put it in as a fraction with pi and then divide it by that, and it didn't work. So convert it to a decimal, figure out what this number is as a decimal, and then just take that part divided by that whole, and that'll give you the percentage, which is what? 1.833, type in a whole bunch of threes, so it comes out nice and round. Oh, actually, it's not a round number. So what do you get for the percentage? Oh, not 0.36, because remember, it's almost 100%. It's gotta be pretty close to 100%. What did you do? Like, again, if pi is on both of them, you don't really need to use the pi. Like, it's just gonna cancel out. So you really just divide that by that. Won't hurt if you say times pi on the top. And what percentage, Kelly, what'd you get? But what percentage is that if you wanted to say it? Yeah, which is almost 100, you said, right? So yeah, you should get 91 if you rounded it 92%. Which makes sense, because it was almost all the way back around. If 2 would have been all the way back around, we were almost all the way back around, so 92-ish% makes sense. Now that you know the percentage that it takes up, what would we do with that if I'm converting to degrees? We know the part is 92%. The whole is 3. Good. So I know that was a lot today. You guys did a good job of hanging in there. That should make next class a lot more bearable, so I appreciate that. And remember, your exit ticket is like example 5. Same thing, same exit ticket pretty much that's on there Monday. That's good. Yes, sir. Tonight, we played Gibbs, who's really, really good. We played Lakeland last week and killed Lakeland, which was a little bit of a shocker, mostly just because we don't have our starting quarterback. If we had her, it wouldn't have been a shocker really. But Lakeland's are in Lakeland.